All right, again, on page 641, number 6, says, you want to determine how many people in the senior class plan to study mathematics after high school. You survey every senior in your calc class. Identify the sample described and determine, oh, that's the example, never mind. Sorry. All right, number 6. A researcher wants to determine how many people in a city support the construction of a new road connecting high school to the north side of the city. 50 residents from each side of the city are surveyed. Identify the type of sample described and determine whether the sample is biased. So again, this is like what you're going to have to do on 1 through 4, where they'll tell you things like this and say, what type of sampling method you use, is this biased or not? Okay, this is kind of like what we have for the first 4 questions on your test. So, what type of sampling method is used if we survey 50 people from each side of the town? Okay, stratified. What is stratified again?
Small groups then.
Okay, small groups and then random, right? So if you consider Minot, for instance, this would be a great thing. Think about the road up to Ramstead, for those of you who are former Rockets. Okay? Some of those roads connecting those to the Broadway was a big deal for them. But if we had, let's say, a high school and we connected the North Hill to South Hill with one road, but we only surveyed 50 people from the north side and 50 people from the south side, that's stratified because you're randomly choosing. You're not asking everybody from the south side or everybody from the north side what you want. Okay? So, stratified would be a good thing. And what do you think, if any, is there a bias at all? What bias do you think, Mason? Okay? There's only north and south. Not east or west. Okay, that could be a determining factor whether it's biased or not. Some people might think that there's no bias there. Because depending on how you split the town, like if we split it down Burdick and say this is the north side, this is the south side, that also includes east and west, kind of. You know, so if you think about it that way, then maybe we don't have any bias there. We're not inflicting our views upon somebody else, necessarily. Okay? Number 7. A researcher records the number of people who use a coupon when they dine in at a certain restaurant. Identify the method of data collection. Okay, again, this is like questions like 1 through 4. Data collection would be things like, did you take a simulation? Did you do a survey? Did you do an observational study? Did you do an experiment? Which one of those 4 do you think it would be? Observational study. Okay, that could be where you are sitting at a booth in the restaurant near the till and just basically count to see how many people use the coupon or not. I would also wonder if some of you put survey. Could you survey them as they leave? Could you ask them yes or no? So having a survey down as far as an observational study, I would take either one of those. Now, you're probably not going to simulate this. You're not going to run a computer program to see how many people use the coupon. And you're probably not going to experiment with it, but you could probably do the other 2. I could see either one. So for that particular answer for number 7, I would take either one. Number 8. Explain why the survey question below may be biased or otherwise introduce bias to the survey. Then describe a way to correct the flaw. And it says, do you think the city should replace the outdated police cars it is using? Again, do you think the city should replace the outdated police cars it is using? And we have to figure out, explain why it might be biased. Jake, what do you think?
Because like to your average citizen every day, most of them don't really care about the police force in any way. So just ask them if we should spend more money on them when we go to other things like roads and stuff like that. Most of them will say no.
Okay, all right. Anything else? There's one key word in that sentence that you guys may have overlooked. If I'm telling you that the cars are outdated, am I giving you my opinion about what's going on? Yes, I am.
How do you do that without, because otherwise if you just try to say, I'm sure we're getting discounts, well then,
Because
people have to lie, you know.
couldn't it be a fact that the cars are outdated?
I did like 4 sentences.
Yeah.
Okay.
Okay, so for that particular thing, the key to it is that they use the word outdated. They're inflicting the fact that outdated means that they need new ones. Okay, I'm telling you they're outdated, so we need new ones. Like, without saying that we need new ones. So as far as the possible bias there, they're telling you that it's outdated. How could you correct it? Could we just take out the word outdated? Yeah. Now, the other thing that the possible bias could be, like Jake mentioned, that, you know, if we got a lot of people in the community that don't necessarily care for what they're doing, and we could use the money for something else, then they're going to opt for something else, right? Okay. So again, those are the types of things that you're going to be asked to do on 1 through 4. Number 9. A restaurant manager wants to know which type of sandwich bread attracts the most repeat customers. Is the topic best investigated through an experiment or observational study? Now, this one, just so that you guys know, this is 100% on you. I can't answer this question for you. This is 100% your opinion. Do you want to make it an observational study or do you want to make it an experiment? As long as you have something that makes sense to go with it, it's right. You just need to pick one. You need to be on one side of the fence or the other. You make the call. So if we're at Subway, for instance, and we want to know which type of sandwich bread attracts the most repeat customers, do you think we should do it as an experiment or as an observational study? I would probably agree with the observational study, because you're not going to experiment and say, or maybe you'll eliminate. You think about Subway right now has how many different types of breads? 6 to 9, somewhere in there, sometimes. Okay? If we were to eliminate all of them and just have like white or wheat, okay, then we might lose business, because some people go to those just because they have those different kinds of breads. So observational study, I think so too. Describe how you would design it. How would you design the observational study then? By recording how much of each bread is sold. Could you do that even on the register? Not even like sit there and have a hash mark. Especially at Subway or Jimmy John's or whatever. I would figure that they would have somewhere to say that, oh, you got a cold cut combo on wheat and it's this. Like, they gotta probably have that on their register somehow. So therefore, they could then look at it later. Okay? Number 10. A researcher wants to test the effectiveness of a sleeping pill. Identify the potential problem, if any, with the experimental design and describe how you can improve it. Again, this type of question is just like what you would do for 1 through 4. Okay? The researcher asks for 16 volunteers who have insomnia. 8 volunteers are given the sleeping pill and the other 8 are given a placebo. Results are recorded for 1 month. What's the potential problem with this? You're only testing 16 people. And you're going to make this sleeping pill worldwide? Probably not good enough having only 16 people. Okay, what else? Is there any other options that you have? Okay, here's the other thing that I have a flaw with it. They're only asking people who have insomnia. They're only asking people that already can't sleep, right? They're not testing its effectiveness on the average person that does do okay sleeping, but maybe need that one every now and then. You know, melatonin is a big thing nowadays, where people say they need it to sleep, right? Not every day, but some days people do, right? It wouldn't be just the people that have insomnia. What, Coop?
It's really bad.
Okay. So just so you know, those are some things. How would we change it then? How would you make it better?
Add more people than not just people with insomnia.
Add more people and people that all just not insomnia. Right. Good. Again, these types of questions are questions like what you're going to see on 1 through 4. Number 11. Determine whether the study is a randomized comparative experiment. If it is, describe the treatment group, and control group. If not, why not, and if they're valid or not. To test the new design of a car wash, an engineer gathered 80 customers and randomly divided them into 2 groups. One group used the old design to wash their cars, and one group used the new design to wash their cars. Users of the new car wash design were able to wash their cars 30% faster. Is this a randomized comparative experiment? Yes. Maddie, how do you know? Yeah. That'd make it easier on yourself. They said it was random. Okay? Now, if it is, what's the treatment? The treatment is that we're using a new car wash system. That's the treatment. The control group is the group that used the old system. The treatment group is the group that used the new system. That's it. Okay? Again, these questions that we just had for 6 through 11 are like what you're going to see on 1 through 4. Now, you're not going to see one of each of those, just so that you guys have that down. If there are only 4 questions, and we just did 6 of them, it's not going to be where all 6 of those different scenarios show up, but 4 out of 6 will. Okay? Then, as I turn the page to the next one, it says a normal distribution has a mean of 72 and a standard deviation of 5. Find the probability that the randomly selected x value is from the distribution is in the given interval. And it says from 67 to 77. Now, you can do this one of 2 ways. First way that you can do this is that you can use the number line situation that we did the first day of 11.1. Or you could do it the second way, which we use the table. It's your choice. It will give you the answer for both of them. Now, remember, with the number line, what number goes in the middle? When we had this curve, what number goes in the middle? What's the mean? 72. And then 1 standard deviation above, what's 72 plus 5? 77. What's 77 plus 2? Or plus 5, I mean? 82. What's 82 plus 5? 87. What's 72 minus 5? 67. What's 67 minus 5? And 62 minus 5? Now, the reason why I'm writing those up there is, again, this is from day 1 stuff of 11.1. This is where we had the numbers 0.34, 0.135, 0.0235, and then in this little spot is 0.0015. And remember, that's a mirrored image for the other side. So I have the same numbers on the other side. So again, bless you, 0.34, 0.135, 0.0235, and 0.0015. Okay, so those are my numbers. Here's the nice thing. If these that you're looking for land on top of these numbers that we just found on this normal distribution curve, then I don't have to look up numbers in a table, and I don't have to use the formula to find it. All I have to do is look at the numbers in red and add the ones that I need to add together. Is 67 on my number line? Yes, it's right here. Is 77 on my number line?
Yes.
Yes. And when it says in between them, you're going to add the numbers in between them. Okay? So again, 67 was right here, here's the wall. 77 was right here, here's the wall. And you want everything in between them. So it's 0.34 plus 0.34, which is 0.68. Or, if you told me 68%, I will give you either option. So if you tell me the decimal equivalent or you tell me the percentage, that's up to you. Okay? Whichever way makes you feel comfortable. Now, reminder to you, these numbers that I have up here in red, those numbers from that 0.34 and the 0.135, those don't change. Like, that's going to be there forever. And that's what a normal distribution curve is. They're always the same. The difference comes when you have numbers that are not on your number line scenario. That's where we have to use the table. Okay? Number 5 says at least 75.
Did you say you're going to have that table for me?
If you need the table, I will give it to you. So therefore, you won't have to copy it down.
Okay.
Like, I'll make a copy of that and make sure you guys have that
Okay.
if you need it. Now, here's the other thing. I could have used the table to do this problem as well. What I would have to do is I would have to find the number that's associated with 67, the number that's associated with 77, and then subtract them. By looking off the numbers from the table, guess what number would have came out? 0.68. Like, if I would have put 67 minus 72 divided by 5, 77 minus 72 divided by 5, looked up those numbers in the table, it would have given me 0.68 as well. But 75, is 75 listed on my numbers? Where is it? Yeah, it's somewhere in here. Probably a little closer to 77, a little bit, right? So it's right about here. What's the word at least mean? Greater than or equal to. I need, so if I put a purple line where 75 is about, I need everything above this way. Now here's the catch. Yes, you could add these three numbers together, the 0.0015, the 0.0235, and this one. But you need this little sliver here. If you just guesstimate, that's probably not going to be good enough. So remember, this is the formula we use for this. X minus the mu divided by the standard deviation. The x is the number that you're searching for. So what number are we looking for? 75. Minus, what's the mean?
72.
Divided by the standard deviation, which was?
5.
And they give those numbers to you, so it's not like you have to go searching for them. What's 75 minus 72? 3. What's 3 divided by 5? I'll give you a hint. It's point. Rhymes with sticks. 6. Good. Okay. So 0.6. So when we go to the table, which was on 598, and again, if you need the table, I will provide it for you so you don't have to waste time on your note card for it. Okay. So I go to the table. And I look up 0.6, and it looks like, to me, it's right here, 0.7257. .7257. But remember how the chart reads. The chart reads from the left of that number. So it's reading everything on the left side of 75. We want the right side of 75. How do I find the right side of 75 then? Subtract 1. Right. So I need to take 1 minus that 0.7257. What number comes out? What's 1 minus 0.7257? Zero, borrow the 1, 9, 2743. Again, on the test tomorrow, if you were to tell me it's 27.43%, or if you just put 0.27 4, 3, either answer is fine. Okay? And the last one, at most 82. Is 82 on the list? Yes. So for this particular thing, when it says at most, what does at most mean? 82 or less, right? When it says at most, that's the highest it can be is 82. Since 82 is on the line, can I simply just add the pieces together? Yes, I can. If it's not on the line, could I still, or even if it is, could I still use the table? Yeah, I could. So, just to show you, if I want to go from 82 and then putting it in orange and all the way down, if I add all those numbers together, what is 0.0015 plus 0.0235 plus 0.135 plus 0.34 plus 0.34 plus 0.135? How much is it? Are you sure?
Why didn't you do the point?
It's so terrible. I'm just kidding.
0.975. Yep, you're right. Just making sure. Okay. Now, for that particular thing, if we did it with the table, could we take 82 minus 72, divide it by 5, and get a number? And then look it up in the table? Could we also do it that way? Yeah. And we'd still should get the same answer. So, just so you know, you got 5 of those on the test, like this. Okay? Again, if you need the chart, I will give it to you. Okay? And the other thing is, this could be something simple to put on your number line, that normal distribution curve that has all the numbers listed in there. If that, and then that way you leave it, this part, like where I have the 57, 62, 67, 72, that stuff, if you leave that alone and just put, this is, 0, 1, 2, like I did before, where I had 0, 1, 2, 3, and then -1, -2, -3. You could use that. That would probably be a good thing for that. Don't forget probably this formula that I have right there. It's kind of hard to see. You might need that formula. But 5 through 9 on your test is like these. And then the 1 through 4 on your test, again, is just like answering your opinion. So as long as you answer it, and then sampling methods, like which type they are. So you may want to have, you might want to have written down like the different types of data collection, like we talked about earlier. Like if it's a simulation, what were the other ones? Simulation, survey, experiment, or observational study. And then as far as the different sampling methods, like you've got stratified, cluster, convenience, systematic, self-selected. You might want to have those down, a little one-word things about what those mean, just in case. Okay? So, anybody else have any other questions about it? No?